Hey guys, so today I'm going to be doing a little board. I haven't really decided exactly what's going to be on the board. I know it's going to be based on the NRF24L01 and I'm going to be cheating a little bit. And instead of putting a full sort of homebrew microcontroller on there, I'm going to be recreating what's on this little breadboard. Now this is an Arduino Nano. In fact, this is a really cool Arduino Nano from Robotyne. I've got one here that I've not opened, but they were really cheap, really cheap. In fact, let me pull it up on the interwebs so you can see it. It was on AliExpress, I believe. Now, it's because Arduino Nanos, they generally run around the £3 mark if you're going to get them in the UK. Right, if I go to my orders, I should be able to bring it up. Should have prepared this bit beforehand. But yeah, I'll be using one of these little nanos, mainly because it's got everything on board. I don't have to worry about creating my own board. There's a lot of parts on here that I don't then need to solder myself. And we're going to use the NRF24L01. Now I was using these little breadboard adapters. They're really useful, but again you have wires all over the place. So brilliant for prototyping, not so good if I want to distribute a few of these around my house. So let me just log into this thing, and then I'll bring up the board. So, in fact, you're allowed to see all my orders, that's fine. So, let me just change my head to a smaller size. There we go. So if I go to my orders, you'll be able to see a lot of things that will be coming up, actually. I've bought quite a few things recently. Now, I haven't been doing post bags either, and that's mainly because they're these ones here, actually. So they're £1.32 each, and these are from Robotyne, and I think they're really awesome. So I'm very pleased that I could find these ones so cheap. I think they're based on the CH340G, so actually quite good little USB chips. They're not the ones that suffer from driver problems. So we're going to be messing around in Eagle and creating ourselves a little board. Now it's generally going to be sort of a temperature sense thing, but I might stick on a DHT 22 or 21 or something like that instead. So, but we're going to wire it up as if we're going to be using an LM35. So let's get started. First off, we're going to need a Arduino Nano sort of layout. Now I think I have one. I'm just going to have to remember what it's called. There we are. Someone else's library, and I can't remember who it is, but if you search for CRE-lib1, you'll get this nice little footprint for a Nano. Now, the thing with this is you kind of remember which way round these go, because you need your USB to be on the edge of the board. Now, if I have a look, and I'll see pin 13 is next to the USB. So the USB is going to be down here. So if I try and remember that when I go to do the layout, that will be good. Now, what else am I going to need? I'm going to need a, 6 pin. Let's have a look. Make sure it is 6 pin. Oh no, it's 8 pin for the NRF. So this one here, I don't know how close I can get with that, but that's the one we'll be using. Or one of the ones. I've got one of these, well, I've got a couple of them with the long sort of extended aerial meant to have better range. I've no idea whether they really do or whether it's a bit of a gimmick, but I've got some of those, so I might be using those. So it's an 8 pin head, but it's a double one. So if I go down to the pin head library, have I gone past it? MNOP. Yeah, I have to do the alphabet in my head. There we are, pin head. And we want 2 times 8. No, 2 times 4. That's right, yeah. 2 times 4. There's 2 different ones here. One that shows the pins and one that doesn't. So we'll just go for this one. Now, when wiring up this bit, we're going to need to know which way around they go, which is why I pulled out the little diagram here. So we know that ground is there on the square pin, and we know VCC is there. So if I make ground on number 1, we'll do that now. Should we do a symbol on it? No, let's not do that. Let's do let's pull out our supply. So if we go to supply and bring out a ground, and we'll then name it, and then that's what we'll do for all of the rest of them. Oh, I need wire there. And so we'll just call this one ground. And then similarly, we need to do the same on the board. Now this board, it's going to slot in using some sort of headers. Let me just grab some. They're somewhere around here. I know you can't see me digging through stuff, but I've got them in here somewhere. Ah, here we go. So I picked up a fair amount of these things. Now these are, I realise I'm quite small on the screen now, so these are going to be difficult to see, but they're sort of female headers, so you can pop things into them. And so anything you've got, like this module is an MPU 6050, which is an accelerometer and gyroscope, but it would slot in like that, meaning that you don't have to solder that in, so you can just whip them out when you want to. Now the good thing with that, for this Nano, is it means I can use it for something else if ever I find this board's not being very useful for me. But it does make things tidier having these things too. So you don't need to do an awful lot of soldering and desoldering. So let's get these wired up. So we want ground there. There should be another ground, there is. And we'll just name that GND. And this one is GND. So because we're going to be I'm going to try and power this with some AA batteries. I'm hoping to use like a 4 little battery pack and put some rechargeables in there. They should be they're at 1.2 volts for most of their life. They will be like closer to 1.5 when they're freshly charged, but if I make sure they're not when I put them in this, then it will be 4.8 volts, which is close enough to 5, but it might mean that we'll have to do some analog reference stuff to find out, to get the proper temperature from the LM35 rather than something that ends up being a bit lower. We'll do a bit of testing. So they're named, but I've not marked them, so let's do that. And this one's going to be VCC. Now that's going to 3 volts, isn't it? Because it's an NRF, so let's pop that onto 3 volts. And let's say 3V3. 3V3. Oops, 3F33. There we go. Sorry, hey guys, I wasn't looking at the chat because I sort of didn't advertise this, so I didn't know anyone would show up. But yes, it's an NRF 24LO1 Plus and an Arduino Nano plus a couple of sensors, maybe just one. I'm not sure yet whether I want to do humidity sensing and temperature or just temperature. What I want to do is a few little range tests in the house, but also somebody created a library recently, someone I like to watch on YouTube. So if I get all this sorted and get the boards printed, then I'm going to be testing out his new library, which looks really, really simple. So it's not like there's a ManicBug RF24 library, which I usually like to use, but this one, it looks a lot simpler. Let's see if I can find the YouTube video that he was in. Let's see. If you can let me know if it sounds all right, because I haven't listened to this yet, so I don't know if everything's coming through properly. That would be great. It wasn't Michael. I'm sure it was more recent than that. Let's see. No, I can't see it now. I'll have to go back through my history and find it. But his library seems really, really simple. Dirty engineer. Am I going to use PCBs.io? Maybe. I say maybe because the company I work for has a facility to create really rough PCBs. So I don't know if I've got any lying around. Yes, I have. I'll be back in a second. So the company I work for, let's just jump to the big camera. So the company I work for can make PCBs, and they look like that. If you ignore that there's a ESP8266 on there. They are just sort of bare copper boards, and they're milled out by a machine. So it's not got a fancy mask on it or anything like that, but they do work perfectly well for little prototypes. The problem with their machine is it can't drill really small holes. It won't do the vias for you, so the holes aren't copper through. They're just sort of bare PCB. So it means if you're going to do a via, then you sort of have to put a wire through and solder at each side, which is fine. It's absolutely fine. But when you produce a board, it does feel nice to get one of those nice sort of. I'll show you one. I have loads all over the place that I've ordered from OSH Park. So this one's OSH Park. Didn't work. Quite a few of them end up not working. This one, what was this one? Oh, this was that Audio Cube thing that I started making and then gave up on. Don't tell anyone that I gave up on it. I sort of haven't mentioned that. I've sort of just let it lie. So this one was the brain board for this thing, and I put the wrong footprint on for the SD card. In fact, it wasn't the wrong footprint. It was perfectly fine as a footprint, but I'd done my SD card connections backwards. So I'd read the SD card connections from the top when really I needed to read it from the bottom. So that was ruined. But I love the solder mask. I love like the really the gold coloured copper on here, and the through-hole plating is really good. But I might be doing it on one of these first. But PCBs.io that I tweeted about the other day from Digistump looks really awesome to me. They're all relatively the same in terms of price, but we're sort of at a time when you're looking at service and features rather than just price, because all the prices are relatively the same. I mean, you're going to look at OSH Park, it's probably about the same. Some of these, I guess, depends where you live. If you live in the country where that company is, it's going to be cheaper postage. But there are lots and lots. Dirty PCBs is another one that's quite good. But I haven't tried them all. Indeed, IT Studio have them. And I think, does IC Station have that now? I can't remember. There's a few things. Inflatable Gangster asks, what's the library called? There isn't this chip here. This footprint here for this Arduino Nano came from CRE-lib1. You'll have to Google it, I'm afraid. I don't have the information on me. I mean, I've probably got it in my history somewhere, but I'm not going to go and look for it. So you'll just have to Google that, I'm afraid. JS7457 asks if there's a cheaper one than OSH Park. I think OSH Park and PCBs.io are probably about the same, really, you know, when it comes down to it. But PCBs.io does look cheaper, but then it's perhaps not as featureful. So you should just if you've created a schematic, you've got your Gerber files, and throw it up and see what price it gives back to you. They all have sort of these live quotes, so you'll be able to find out very quickly which one's cheaper. And it all depends where you live as well. So postage to certain parts of the world will be much, much more than if, say, I don't know, PCBs.io is probably China-based, OSH Park is probably China-based, but so if you live close to there, it will be cheaper. I've got a new mug, The Amazing Spider-Man. It's actually got a picture of me on it that my dad took when I climbed a tree for some reason. I can't remember why I did that. It wasn't even that long ago. I think I was about 30 years old. So anyway, let's jump back to the footprint. Let's make sure we know what we're doing. So we've got CSN, IRQ. IRQ we don't need. MISO, Mozzie we need. Or MISO. I don't know how you meant to say that.
So let's find out what pins those are on. Arduino Nano pinout. It's annoying to remember these. I mean, there's only like, we use these all the time, these SPI pins, but I always forget which ones they are. So Mozzie is on pin 12. Oh God, which one was it on the NRF? Oh, the library I was talking about for the NRF library. I don't know. I really can't remember. I don't even know if there's a way of me finding out from my history on Google. Maybe there is. Ah, there it is. Right.
All right, I wanted to show something.
Okay, it's this dude here. I know I do. I don't know if you can actually hear his voice or anything, but it's Dee Parson. Now, he's the creator of Mom's Timer. And you'll have to tell me if it's too loud for the... oh, there's the live dashboard. Let me just get rid of that. That should not be on the screen. There we go. So, yeah, it's the NRF Lite library. So let's jump to it. There we are. We can get rid of this video now. So this is the library that I'm going to be trying out. He's created it himself. He's written all the code himself. I'm sure he's borrowed a little bit from the RF24 and how that works, but he's got several examples in here, one working with the ATtiny85, which, you know, it sounds intriguing, but I don't really want to sort of use an ATtiny85 because it doesn't really have a lot of capability to do very much that I'd like to do. So I'd like to get several sensors connected to one thing, and so the AT85 is probably not going to be very useful, but the Nano is extremely cheap and very versatile. So yeah, that's the NRF Lite library. So let's jump back. We can jump back to our schematic now. So it's MISO and Mozzie. Let's go for MISO first. And I'm pretty sure that was pin 12, wasn't it? So let's just put 12 in. Oh, actually, no, let's put... just so we know. And just be aware, I'm going to make some mistakes along the way, so feel free to tell me if I'm doing so. Let's see. No, it was actually pin 11. See, I could have made that mistake and none of you would have said a thing. Right, so this one is MISO. How do you guys say it? MISO? MISO? I say MISO and Mozzie. I don't know if that's correct. It's just what it sort of sounds like in my head, at least. So we've got Mozzie next, and that's just here. Bit long, doesn't matter. And that one goes there, doesn't it? So, does it? We'll find out in a second. Mozzie. Okay, next we have we want clock. So where is that on the Nano? Is that pin 13? It is pin 13. Okay. Oops. So, do you know, I don't know if you guys have ever heard of, is it Easy EDA? Let's pull it up. Easy EDA? Yeah, I got contacted by Easy EDA recently, and it's sort of a schematics and prototyping thing for PCBs. And they asked me if I'd make a video about it, but I don't know if you guys have ever used this thing before, have you? It's an interesting one. It seems rather simplistic in comparison to Eagle or Altium or God, what are the other ones? KiCad. It seems rather simplistic, really. So you just create a new schematic and then you drag bits in there. Well, drag, click, that's it, and you just click them in. But the thing is, it doesn't really have a lot of parts in here, so you can create your own, but yeah, it doesn't seem to have an awful lot. It's got a few ICs, a few logic ICs, but not an awful lot in there. So I haven't done a little video on it yet. And
and it seemed a bit dodgy. They sort of offered me money to do it, which I'm not really about. I don't really do that. I don't do any of this for money, so it threw me off a little bit. When someone offers you money to do a review, you kind of think, ooh, that product must be really bad, or loads of people have said no before. So let's carry on with this anyway. So they're getting sidetracked again. So what was this? SCK, wasn't it? Oh, crumbs, where was it? My memory is terrible. It wasn't even there. It was above that one. There we go. Oops. What part of England do I live in? I live in Leicester. We just won the Premier League. It probably won't tell you much. But yeah, I live in Leicester. It's not where I'm from, but it's where I live now, and have done for about over 10 years. Close to 14 years, I think. Something like that. It's a long time. What about you? Where do you live? Since you asked me. What else do we need to connect here? So we've got those two left. So we've got CE and CSN. I don't think we connect CE. Ooh, do we? Oh look, someone's actually done a little diagram there. That might be easy to use. CE. What does CE stand for? Does anyone remember? CSN we definitely need to connect, I'm sure of it. Let's find out. Oh look, someone's even got a... Hang on a minute. Okay, well they're doing pretty much the same thing I'm doing, and probably years ago, but they're using the DS18B20, which is one of those Dallas chips, which I'm not going to be using. That's one of the it requires the one-wire library to communicate with it, which I don't want to do. The LM35 just kicks out a voltage, so it's an analog reading, and then you convert it to a temperature. So that one's really, really easy. So what have we got left? Oh, actually, I need that window back, don't I? Because I'm not going to try and remember all of the connections. Oh, dear. Okay, so this dude here, let's jump to this one. It's just a bit easier to understand. So we've got, oh, he's flipped his round, which is quite annoying. Let's see one that hasn't flipped it round. They've also flipped it round. And what I mean by flipped it round is my head is oriented in one way for the board I'm creating. So it's a little bit annoying. But this person's put CE on 7 and CSN on 8. Has everyone else done that? CE 7 and 8. Yeah. Okay, let's do that. Okay, so C in was underneath ground, wasn't it? CE, rather. And we'll name that CE. And that was 7. You know, for the longest time, I say that, it's probably only a year, I would have just done a wire from whichever pin it was, and I just snake it around without naming them, because I didn't know you could do this. I didn't. Oh, we've already done that. Because I didn't know that was important. Well, it's not just important; it just makes it a lot cleaner to look at. And then I think that one is CSN, isn't it? And then IRQ is the bottom one, and that was pin 8. You know, when I do these live streams, it's always quite interesting because you guys get to see how rubbish I am at electronics. Dirty Engineer, I wasn't thinking of the voltage reference pin, no.
That's, yeah, no, the voltage reference pin is for the processor to get its reference with the voltage, isn't it? So it's not that. I don't know what I was thinking. Just ignore it. I'll do some reading up on what the V-in pin is, but I didn't think you're meant to power an Arduino through the V-in. I thought that gets the voltage from the jack, the power jack, essentially. And since the Arduino didn't have a power jack in this case, I didn't think it was appropriate to use it. I thought it was just what's coming from the USB. But I was obviously wrong, so I'll look it up at another time. Okay, we've got everything pretty much wired up there. Let's see if we can find an LM35. Do you know what? I don't need to. Let's not get an LM35. Let's just pick up some pin headers. It's a 3-pin device, so it's in the TO92 type package. Should we get 2? Yeah, let's do 2. We'll wire one up as a DHT22 as well. So I've not been, well, I've been on holiday for a little while. Has anyone seen anything good on the news? In terms of Arduino stuff or microcontroller stuff, anything really. I recently discovered something called the CHIP microcomputer. Let me show it to you actually. I'm really excited. It's by this company called The Next Big Thing, I think it's called. This is it here. So, well, sort of it, I guess. This is the Pocket Chip, which is like a little kind of, I don't know, 8-bit Game Boy, I guess. Were Game Boys 8-bit? They might well have been. But this looks pretty cool. It's muted, that's good. So, okay, that's a bit odd. This is it. How cool is this? And what it actually is one of these little boards here. They've got Wi-Fi on board. It's got a really massive ARM processor on there. And I've just ordered one, and they're $9. So they should be shipping out in June, which is now. So I'm hoping to receive it quite soon. And the reason I bought it is because I'd like to make a, not a little Game Boy, but I'd like to make sort of an internet radio, essentially. And for $9, you can't buy an internet radio, as far as I know. So, well, you could use your phone, I guess, but I'd like to sort of make something where I can tune in radio. I was looking at DAB radios. I've made an FM radio before, made a few FM radios before, but DAB radio is not accessible as a hobbyist device. You can certainly buy an off-the-shelf DAB radio, control it with a microcontroller if you want to, but you'd have to be pressing the buttons with your Arduino or PIC or whatever you want to use. You'd have to be doing that. You can't not easily, you can't sort of reverse engineer the communication protocol. Mainly because it's all sort of closed source, and you can't buy the DAB radio chips or modules very cheaply. There is one called the Monkey Board, I think, and it's a sort of a DAB radio board, but it's about 50 quid, so it's very expensive. And I think if you want to get their closed source stuff, you have to sign an NDA, which I don't really want to go to the effort of doing. So I'm going to go with internet radio. It's probably going to be higher quality than DAB. The bit rate's going to be a lot larger. And I guess there's just more things you can listen to on internet radio. Yeah, I mean, you still have to get the streams, but it means you can write the whole thing yourself, which I'm excited about doing. And I can have it, well, I won't tell you everything because I want it to be sort of a secret, but I'm going to have it sort of tuned in a very interesting way, hopefully. Anyway, let's carry on. What was I doing? Oh yeah, I wanted to see. I put an LM35 in, didn't I? So let's just look at the pin out. I'm pretty sure it's like VCC out and then ground on the other side. So let's do that. So this is going to be going to 5 volts. Oh, I haven't looked at the chat in a while, sorry. I forget to do that. Oh, Simon says he's ordered one for the Pico 8 games. Yeah, exactly. That looks really cool. I'd love to get one of the little pocket ones. I wouldn't want to do any development on that one. I just want to have a little games thing so I can play other people's games. But they do look very cool. And Nathan says, why not the Raspberry Pi Zero? Yeah, I've got one of those down here, and I've not used it. I will be using it for some things, but the problem with the Pi Zero is it's not much smaller than that pocket chip, but audio out is an issue with this. So you can use that HDMI if you want to, but getting just HDMI audio out is a bit of a pain. And then you've got the problem of there being one USB for power and one USB out. So internet was going to have to be through one of those USB on the go things. So I'm not quite sure it's exactly suitable for what I want it to do. And I think the little pocket chip has Wi-Fi on board, which removes the need for that USB. It also has a USB on it, so that I can use a little plug-in pair of speakers, which I've already made, and have it work like that. Or I can use the... does it have a USB on board, or am I talking crap? I might be talking crap. Hang on. I hate it when I get things wrong. Let me check. Documentation. I don't know. Let's have a look at the documentation before I start talking crap. The chip. Let's see. Connect to Wi-Fi, Bluetooth, blah, blah, blah. Oh, it's got Bluetooth on board as well, which is handy, but not really what I need. So we've got... Yeah, it's got a USB on there, so I could plug in my my little speakers that I've made, or well, anything really. I could use that for expanded storage if I want to, that kind of thing. But really, what I'd like to do is just use the TRRS AV connector. That's one of those 4-pole things, and it gives you the audio and the video out as well, so you've got like composite video coming out. But I don't need video for what I'm doing. I may have a little LCD display, but I don't even think I need that, so we'll be doing something else with it. But the Arduino Zero is great, but not as useful for all the kinds of projects that you would use a bigger Pi for. And the chip is essentially the middle ground between a bigger Pi and this one. There are other boards out there though. One I picked up recently that I was going to do a little video on today, but I didn't get around to it, is the Orange Pi PC. There are several versions of the Orange Pi. There's the Pi Plus, and then there's the Pro, and some other ones that I can't remember, the 2, I think. And they're interesting ones. They're like Raspberry Pis, but they're not so well supported in the software area. The hardware looks nice though. So I've got one of those to play around with. I'm not sure what I'm going to do with it yet. It might become a little retro Pi thing in the end, which is what I'm using my Raspberry Pi 2 for at the moment. The Raspberry Pi 3 I'm not doing anything with yet. I'm excited about it though, because the performance is going to be so much greater. Anyway, let's get back to this quickly. So this one's VCC. So we need a wire going from our 5-volt pin, which is here. And that's just going to go to our batteries. In fact, let's pull out this one here as well. That's going to be our battery pack. And because we're using batteries, I don't really need to worry too much about sticking any extra capacitors on there. But I may do. The current draw on this thing's going to be minimal, so it's not going to be spiking current or anything like that and making the voltage drop and go up again. It's not going to do too much of that. So let's change this to not VCC. What do we want? 5 volts will do. And this one's going to be ground. So it shouldn't be a very noisy board really. Oh no, hang on, what did I want to do that one for? That's VCC, isn't it? Or 5 volts is what I called it.
And then this one is ground. And this one's going to be out. So let's send it to A0, the simplest one. And we'll call it out 1, because I'm not sure if we're going to add anything else that might be analog. So we'll leave it as that. And then let's get all the names up, shall we? Okay. Out 1. Oh, hello. That's not named, is it? There we go. I should probably click save at some point. Okay, so we've got our NRF24L01 all wired up. We've got the Nano all wired up with everything that we need from it right now. And that is it, I think. Let's jump into the board. Where's the button for that these days? Does anyone remember what it looks like? File. Switch to board. Okay, there should be a sign for that somewhere, shouldn't there? A button. I can't see it. Right, so it's created up as a board for us, which is incredibly simple. I'll just have a look at the chat. I don't want to miss people's questions or, you know, abuse. Angel says, I've got an Orange Pi PC and mine tends to get somewhat hot. I have heard that they sort of need underclocking, or they need some kind of heatsink on there with a fan possibly. So I don't really know. It depends if you run it a lot. If you run it, you know, 24 hours a day, if it's a server for you, I'm not sure. Yeah, they are super cheap, aren't they? Mine was £10, the Orange Pi PC. That's like the basic version, really. So that's what I've gone for. And stupidly, at the time, I didn't buy a cable to plug it in, because it won't be powered from the USB micro. It has to be powered from a little DC jack. But it takes 5 volts. So for some reason, it's not allowed through that micro thing. I think it can boot through that, though. But it won't provide power to the board. So you have to buy this little USB to DC jack, so it's 4 millimeters times 1.7, and it's center pole positive, I think. But I don't have one of those because it's tiny. It's literally a tiny little DC jack. So I've had to order one, which means I can't use the board for a while. You can power it via the GPIO pins, but I didn't really want to mess around with that because, one, I don't know how much current it's going to pull. They recommend a 3 amp power supply, which is insane. And I don't want to put 3 amp through these tiny little wires I've got, because, one, they're going to get warm. But also, what if I mess up and I get into the wrong GPIO? Wouldn't that be awful? I mean, it's only £10 kind of awful, but I don't want to have to wait another 2.5-3 weeks to get it from AliExpress, which is, I think it's the only place you can buy it from, that Orange Pi PC. Fifth icon from the left. Haggerty. Oh, there it is. It was there the whole time. Damn. Well done. Okay, so actually, I keep reading your name as Angle. It's not, is it? Angel. What kind of current does it draw? Let's say it's not doing much, or it's just playing a video or an audio file or something. What kind of current does it draw? Or just when it's idle? I mean, that will give you an indication of what the sort of system's demanding. So let's move these bits around. Going to have to try and remember. Oh, actually, do you know what I can do? Because we know where ground is on this thing, because I need to make sure it's not going over the board, and it needs to be pointing. I'd like it to be pointing up this way. So it's going to cover a bit of blank space, but I'd like to make the board as small as possible. If we put in our ground plane, Let's move these around. Give myself a little bit of room either side. I don't need much though. Oh, actually, let's move this over. There we go. And this can come over a little bit. How much does it? Oh, I've lost it. There it is. So I think I want it to go that way. So if it goes that way, then this can be quite flush with the board, I think. Let's see. Yeah, I think that'll be okay. And then we can have this pretty close to there. And it means it'll overhang a little bit. Unless I want some screw holes. Do I? No. I don't want any screw holes. I'm not interested. And our LRM35 is going to be extended a little bit by wires, so not an awful lot. I don't want to increase resistance on it at all, but I'll do it a little bit. Just to take it out of the box that it's going to be going in. So I'm hoping that's probably going to be bigger than my 3 batteries together, isn't it? Still, it's fine. I'll put those in a separate case. That'll be okay. And I'm going to 3D print a little case for this thing. So, God, have we been going for 53 minutes already? And I've barely done a thing. Isn't that amazing? This is kind of just what happens, isn't it? So, we want to wire pretty much everything on the bottom of the board if we can. So let's throw up our ground plane onto the bottom. And we're going to, this is how you do a ground plane. So we're going to name it GND. And then we also want to do the same with the top. Now, because I'm going to be hopefully using as little of the top as possible, GND, I'm going to try and route everything on the bottom. Oh, now you'll see there, look, it's got this, it's got some settings in here. Well, what am I looking at? Tools, tools or options. Design rule check, and if I load the correct one, it's the default, obviously. Documents, Eagle. We'll just go for the OSH Park one. I think that's what this one is. Yeah, there we go. So the design rule check, with that, it was sort of specifying how much space was needed around each component and how close the thing can mill out or whatever the area is. So it sort of ruined the look there a bit. So I just thought I'd change that back. Because this is being milled, it's actually quite accurate and can create quite small areas on here. So I don't know. I've no idea how close this will get. Let's have a look if I can. I don't know if I can show you that very clearly. Is it going to focus? Let's see. No. Oh, hang on. I know I'm looking over there now, but I'm trying to sort this camera out. There must be a way of going to the properties. Properties? Configure? Ah, right. I've turned the autofocus off. So let's see if I can do it now. Is it better that way round? Oh no, don't look at that side. don't look at that side. That side is where all the terrible stuff is. There we go. So you can see actually it creates quite fine little sort of traces, sort of areas around where the holes are. So it actually can do very fine work, which is nice. So I'm quite content that it looks like this, so I'm all right with that. Let's go back to me having a small head, even though I have quite a large head, really. So, if we remember correctly, we don't need to remember, we can look it up actually. So let's jump back to our NRF pinout and our schematic. So we wanted this one to be pointing upwards, didn't we? So no, we didn't. Actually, we want ground to be in the bottom left-hand corner. Okay, that's pretty simple. So we want it there. It's not giving me a lot of room to route, so we might have to change our plans a little bit here. These connections, the ones where they've got pins right next to them, are really, really annoying in this regard, and that you have to sort of route around them. So if I, let's bring this out a little bit. I'm going to need a little bit more space, unfortunately. You know, maybe that would be a good thing, because maybe it will mean I can have those 3 AA batteries. Do I have any around? I do. They're not actually. I meant 4, actually. So 4 AA batteries. I don't have a holder that's 4, I don't think. I have ordered some. You might have seen that on the thing. So if it becomes that size, then I'll be perfectly happy if that board fits just on top of the holder that's going to have those 4 batteries in. You'll notice that some of those were 3.7 volt batteries, so I won't be using those. So we'll make it a little bit bigger so that I can route around this. And we're going to have to make our ground planes a little larger as well. Now, that should be sufficient, hopefully. So let's just start going at it, shall we? So let's see what the wire size is like on this. Bit small. Rather a little bit bigger. That's okay. So we want to be on the bottom of the board, because that's where these are going to be soldered to. If you look at this, look at the sort of snap position. It's quite large, isn't it? I prefer, whenever I start Eagle, it always resets to this very annoying 1.27 millimeters, and that's great if you want to make sure that your pads are evenly spaced and stuff. But I don't really like to do that when I'm routing. So let's do 0.1. That's better. Gives us a little bit more of a smooth action with it. So nothing fancy here. It can be completely rough and ready. Oh, that's my phone. Something about wallpapering. I know that sounds boring, doesn't it? My mate's doing some wallpapering, and that's not interesting, is it? For heaven's sake. I've been doing this too long now. It's starting to become uninteresting for all of you, I'm sure. So we'll route the bottom of this board and we'll get the rest done. I'm going to have to give myself some more space because I can't go through these pins. I could, if I use very thin wires, we could do that, but thin traces rather. But oh, actually, we're going to move everything up because I like that little registration mark at the bottom. It's getting larger and larger, isn't it? It's becoming more and more like having it on a breadboard. So, oh yeah, of course. Let's move these up. These don't have to be perfectly square. They're just as long as they cover the board area, then it's fine. Oh yeah, look at that now. Let's just get rid of that. And we'll move this. This can stay here, actually. And then we can even bring that over here. No, actually, we'll leave it at the top. Leave it up there. Right, let's get this wired in. So this one's the topmost pin. We're going to have to do a few vias, I think. Let's do the one that's furthest away. Oh, we're going to have to bring it up. There. This is going to be ugly, I can tell. Right, so you'll wonder why I've done that weird line there. Let's just get rid of this trace here. That seems to be connected. Oops. You'll wonder why I've done that. Well, I'm sort of working from this pin first, then we'll do this one, then we'll do this one, and then that one, so that I can sort of arch them around a little bit. So where's the next one? Where's going to... Is it this one? That one there, yeah. So we'll bring that along. Sort of follow the same path. We don't have to do it exactly. This is literally just a prototype. If I were going to get this done at OSH Park, I would do really, really thin traces. So I would do, let's pull one out here. I would do something like maybe even smaller than that, which it won't let me do. But I would just go through like that and then bring it down to wherever it needed to go. Oh, maybe not that one. Well, actually, we could just come in here and do that. That's if I was getting it printed somewhere that I knew could achieve that. But I know that my work can't do this. It would just there'd be something wrong, and the drill or the milling part of the machine holding the drill would just sort of veer off a little bit, or some of the burr that would come off would damage some of those very, very thin tracks. And because it's got no solder mask, there's nothing to protect those tracks once it's finished. So I could easily just scrape it with my nail and then it would break. So larger tracks are better with this kind of board, with this kind of prototype. So we're just going to try and fit it all in. It's just an annoying... Oh no. What size was that track? Was it this one? Oh, come now. That looks a little bit larger than the others, but that's not a problem. And that's on the top of the board as well. So let's jump to the bottom of the board. And we'll do the next one. So that one goes over there. That one goes there. That one goes there. That one goes there. Okay. Bit tricky, but doable. Okay, let's bring this one up and down and around. And then this one can come down here and across. And then we're going to jump to the top side of the board for this one. And it's going to automatically put in a nice via for me, which I'm going to have to change the hole size. Oops. Going to have to change the hole size for. Because again, look at how small that hole size is there. It's not very large, but we can change that using this, whoops, the spanner section here. Is it drill actually? It might be drill. It is drill. So if we change the drill hole size to, let's change it to 1. And that gives us a fairly large hole size for us to put a wire through and solder both sides. Because again, this is sort of just a copper clad board, so it's not going to be through-hole plated. And we're going to have to do a few of those. In fact, I've just done that wrong, haven't I? Let's take that away, and that there, and that there. Because I needed to go, again, onto the bottom side of that board, didn't I? So let's pop that there, change to the bottom, and then go across. And then it's kept my my hole size preference there. And then we've got 2 more to go. So that one's going up there. That's fine, we could do this. And then we're going to drop it there, and we're going to take a little via from here. Now all of those other tracks are on the bottom side of the board. Oh no, wait, these ones are too. Hang on. Foolish. Let's try that again. Hey Wesley, how are you? Are you playing any games tonight? I know you've gotten into your online streaming at the moment. Quite enjoying it, I have to say. I'm a big online gaming fan, and I like to watch other people play games. And that sounds really weird. People find it odd when I tell them that what are you doing? What are you going to watch on TV? I'm not going to watch anything on TV. I'm just going to watch some people play games. There's this group called the Squadron, TGN Squadron, which I really enjoy watching at the moment. And if you like watching people play games, then I would encourage you to take a look. They're really cool. Right. What have we got left? 1 pin. Oh no, wait. Maybe not. Maybe not 1 pin. There's quite a few up here. And again, we're going to go back and make sure that we've done everything correctly.
I'll make sure that we don't need any pull-ups or anything like that on any of these lines. I don't think we do. It's not I squared C, so we probably don't. So I need to jump into another via here, and then we can come out of the via just there and sort of follow the line here, and that should be fine. Okay, that's all right. I'm happy enough with that. Can we give ourselves less board space if we want to? Not really. We've sort of packed out this 4-lane highway that we've got there, unless I was going to make the traces any smaller, which I'm not going to because it just makes manufacture really difficult at work. So we'll settle for that. I mean, working on a breadboard is just fine, but I want to be able to put it in a box. So now this is the LM35, and this is our little power thing. So I'm going to put the power up here on the edge of the board. And I'm not going to put a pin header in there. I'm just going to solder wires to it. So actually it can be on the bottom or the top. It doesn't really matter. So let's take it from... Let's go from the top actually, and we'll solder through the bottom. There's literally going to be maybe 40 milliamps, 40, 50 milliamps going into this board, so I don't have to worry about trace size here. And still, that would be good for like an amp anyway, so it wouldn't matter more than that actually. And then this is our LM35, so lovely, easy routing here. Now this is where our NRF's going to go. Sorry, I've just got to reply to this text message now. Do you want me to make some lift music while I do this? Do 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 do. Is that lift music? It might be. For 12:30. Talking about lunch. I know it's not very important. I've got to reply now though because it's getting late. It's almost gone 10. Well, it's gone 10. It's gone 10. Okay. We're going to have to wrap this up in a minute. Finished. Live stream. Right. There we go. Right, finished. Throw that over there. I don't need it anymore. So this is our LM35. Now we're going to extend this off the board a little bit with sort of wires, and then we'll put some heat shrink around it. So this is our output. We again want that on the bottom. And then we need 5 volts here. There we go. And that's pretty much it. Let's jump back to our schematic and make sure that we've connected everything properly. Now I did have this other one here. Now let's have a quick look at what a DHT22, is it DHT22? Yeah. Let's see how they're wired up. I have one lying around, but we're just going to use the images section. Do you know, this is probably, if I were to give you a bit of advice about how to learn things about Arduino, if you need to have some information really quickly, Google image search is fantastic. Look through the images, and if loads of them look the same, then you're probably onto a winner on how these things are wired up. Really is an easy way of finding out. So let's see. This guy's got a resistor. Is that 7.5K? Is that what it was? I think it's right. Let's see. 10K. Okay, so it's a 10K pull-up resistor, and we've got data going into pin 2. And I didn't know it was 4 wire. I thought it was only 3. I guess not. I guess it's 4. Well, that's fine. Let's bung one of those on the board as well, and we can use them if we want to. So it's 1, 2, 3, 4. So it's power out
Pin 3 is not connected according to this schematic, but it is on this one. So pin 3 on this one goes to ground. Pin 3 on this one is not connected, not connected, not connected, not connected. I'm going to go with it not being needed to be connected. So it's VCC out and ground. Very similar to the LM35, except it has 4 pins. And this one requires probably the 1-wire library. So let's jump back into our schematic. We can delete this one, and then we're going to be adding a 4-wire one. Let's see, there we go, that'll do. Are you, Wesley, you're trying to hack an LCD at the moment. What kind of LCD is it? Is it one with a driver chip or anything like that? What are the HD chips, or it's Hitachi, isn't it? But it depends. I don't know what one you've got. What games are you playing at the moment, Wesley? Let's see. So 1 was VCC. 2 was out 2. 3 was not connected, and 4 was ground, wasn't it? That's right. So we'll name that one G&D. Yes. This will be out 2. And this will be 5 volts. Actually, no, I've just done that wrong. Let's delete that. And we're going to move the whole thing over. Because if you remember, they had a pull-up resistor on the outline, didn't they? So we also need to do that as well. So let's jump down to resistor. EU resistor, what do we want? I don't know which one's which. Let's see, 5 millimeters, 15 millimeters. Do you know what? We could use an SMD one. I have some SMD ones. Let's use one. So we'll go for 1206. Doesn't need to go there. It needs to go right there, and that's going to go to VCC. And if I remember correctly, it jumps off after the resistor. No. There. That was close. There we go. So let's name that one out 2. Okay, we are almost good to go. So out 2's there, ground's there, and 5 volt is there. Click save. Jump back to our board and let's get this done really quickly before it gets to 11 o'clock, because I've got some stuff to do before bed. I've got to go and get my football kit ready for Monday. And I've got to get all the bibs ready as well. Otherwise, I'll be in trouble. That's going to get in the way of the NRF. Bugger. Get rid of that. Okay, so that needs to go there, because otherwise it's going to get in the way. That can go there perfectly fine. That can also go there. Which way round was that? So that's with the chunky bit sticking out. Is it still going to get in the way? Let's move it up a little bit. And this one can go up a little bit. In fact, let's unroot some of this. So Wesley says he wanted to use his own power supply because he wanted to use it in his car. So stepping from DC to AC back to DC is inefficient. So I figured I'd bypass the monitors and build my own power supply. Yeah, it is pretty inefficient. But your car's sort of, I guess if it's, sorry, what do you mean DC to AC to DC? So you've got your DC in your battery, and then from your alternator thing, you've got the AC coming out, charging your DC battery. Is that? I'm not sure what you mean. Rocket League I have heard of. I've got Rocket League, in fact, and I'm terrible at it. I really am bad at Rocket League. Right, let's pop that there, and that can go there again. Oh, of course, it would have to be. I've used an SMD, haven't I? Why have I done that? Okay, we're just going to switch this out because I forgot that we were doing this. So something like that one will do. Okay. Yeah, that's perfect. We'll use that. That's not going to get in the way in the NRF, so we're fine. And it can all go on the bottom of the board. And let's unwire this stuff. The monitor is designed to plug into a wall and run off AC, so I wanted to run it off DC battery. I need to bypass the monitor's standard AC plug and power supply. Yeah, that makes sense. Sorry, I didn't really understand what you meant there. You're absolutely right, though. It is more inefficient than converting. It's more inefficient to convert your mains to DC than just use your DC power source. And let's... Well, that's a whole bunch of messy, isn't it? Look, I don't care. We'll probably put a cap in there, actually. Should we do that? Let's put 2. So I don't really need large ones, so let's go for a... Actually, I don't even need to name the values at the moment. Let's choose a nice looking thing. Oh, these are not polarized. So let's choose a polarized one. They're only little, so that one will do. And let's put them across 5 volt and ground. So we're going to have 2 because I think I might put a 10 microfarad and 100 nanofarad in there. Right. How massive are they? A little bit bigger than they need to be, but it's just the footprint, doesn't really matter. The cables will splay out a little bit, so it's not a problem. There will be fine. Let's do that. And then we'll bring the power supply through them here. That's fine. Right. There we go. And just one more from there to there. And then we need... They've got their data going to 2. Is everyone going to 2? Maybe that's a limitation of the library they're using. That's fine. We'll also do ours to 2 as well. So pin 2 we want to go to. It's going to be on the wrong side. Still. We'll figure our way around. So that's out 2. Yep, so we'll connect that up. And we'll just give it a name. I'm sort of rushing now, sorry. I don't mean to. So, we need to get all the way over there, which we can easily, in fact. We're just going to jump onto the top side of the board. And zoom over there. Boom. Done. Okay, so I'm going to leave it there for today, I think, because I'm getting tired. It's coming close to 11 o'clock. It is now 10:30. So thank you very much for coming along. I appreciate it. I didn't expect anyone to show up, really, because I
I didn't tell anyone that this was going to happen, or that I was interested in just throwing the camera up and doing this board. So I'm going to get this board printed out tomorrow, in fact. So I should have it on Tuesday, not printed out, it's going to be milled out, along with another board that is going to be throwing together some other bits, which is one of these, which is a Nano, but it's got an ATmega 168 on it, which is basically a pile of crap. I mean, in comparison to the 328, it's pointless, because the price difference between this one and the 328 was 20 pence. But you know, when you sort things by price and you just buy the cheapest one and you don't notice it says 168, that's what's happened to you, really. You get these ones without pins, which is annoying. Anyway, I want to use it for something else. I'm going to be using an SD card on it, which might steal too much memory, I'm not sure. We might have to replace it for the 328. And also one of these MPU 6050s. Now, I'm doing that because the students at the university where I work, they have this thing called Formula Student, where they have to create a race car. Let's just, I'm not doing any more schematic stuff, so let's just jump to this one. They're doing this thing where they have this race car that they have to build in a year based off these rules schematics that they have. The formula, I guess that's why it's called that. You have Formula 1, Formula 2. They're based off the design of the car that people are allowed to use. Now, the students have their own thing that they have to use, and so they have to build their car from scratch. Generally, they can reuse parts of the car that they had last year, but the chassis will have to change. That means the wheelbase is going to be different. They change the length of the wheelbase and where the suspension can go, how far forward your seat needs to be, the maximum length of the chassis and the power output of the engine, all the maximums and minimums that you're allowed. So they change all that kind of stuff. So they have to do it every single year, and that's why they change it all the time. And I'm sure Formula 1 change theirs all the time too. Anyhow, they wanted to see what kind of forces were acting on the car at various points. So they wanted to see what kind of G, essentially, it was pulling in corners, and what happened when they brake, how quickly do those brakes kick in. You know, you can feel it, but maybe it's not enough to do that. Maybe you need some numbers. So we're going to put together a little accelerometer thing with an SD card to monitor the data and to record it, and maybe throw on a real-time clock as well to do it that way, or maybe throw on an NRF2follow-on so they can view it in real time from like a little base station and have that base station record the data. I'm not sure, but I'm putting together a little prototype with those three things on it, and so I'm going to get that printed out and then they can test it from there. So that should be interesting. So I'm going to get those two boards done this week, and then we'll be talking about them some other point. I may just reserve this just for live streams because it's kind of fun just to do this. It means I don't have to really do my research or set anything up, which is a relief, honestly. You know that video that I did the other day? I don't know if you watched it. If you did, then it's the Form Futura wood filament one. I swear to God, I've never put so much work into a video, ever. Each one of those prints probably took around 2 hours to print. So I either had to design it, the tree, for example, took hours and hours and hours and hours to design in 123D and also Fusion 360. Mainly because I was learning how to use those programs at the same time as designing it, but also it just took time. It just takes time to do things like that. And then there was the Hacksmith logo. I had to steal his logo without permission, and and then I put it into. Did I do it in Fusion 3? Yeah, I did it in Fusion 360, and I sort of traced around it and then created a solid object and extruded it out and created this little round bit around the outside and stuff. And so all of that took a long time. So that video probably took me the better part of 2 days in terms of actual time. We're talking working days, so let's say it's like 14 hours. The better part of 14 hours to do. And this one has been, what, an hour and a half. So kind of easier, really. Anyway, thank you. Oh, someone's here. Mr. D. Parson is here. I don't know what your first name is. It would be lovely to know. I was talking about your library earlier. Just got here, but in case it matters for clearance, the LRF is about 30 millimeters in length. I tell you what, we can just measure that now. There's a measurement tool in here somewhere. The icons have changed. Is it that one? That looks like it. Let's see. So it needs 30 millimeters in clearance. So let's measure from there.
Yeah. What does that say? It's back to front. 24, 30. I wish you'd never shown up. It's not going to fit, is it? It's not going to fit. Have I got a ruler here? I do. Let me see. It says you don't need those wires underneath the Nano as the pins are on both sides. I'm not sure what you mean about that. The pins are on both sides. Oh, yeah, you are right. They're on both sides, but because I'm going to be soldering this onto the board. Sorry, this is Dirty Engineer I'm answering. I'll solder this onto the board. I won't be able to solder the top half because it will melt the plastic. So it will not be a good connection on the top. So I'm going to just use the bottom because it's a bit safer to make sure that that will be the case. So the wires just make it easier, and I can make sure that it works that way. So you are right. It's 29 millimeters according to my ruler, and so do we have 29 millimeters from there? Let's find out. Where's the ruler? Can I measure just from there, please? No. I don't understand why it's going to jump to... Just measure from there. No. Okay, let's just draw something. Draw a line there. Thank you. We'll take that away in a second. Where's the ruler gone? There. Measure from there. There we go. So I need 30 millimeters here. Well, 29. Oh, look. That's going to work out just dandy, hopefully. Yeah, we're fine. Thank you very much for pointing that out and making sure that I didn't mess up. Dave Parson. Dave Parson is the guy with the library that I'm going to be trying out with this little board that I'm just knocking up. So he's created, what was it? NRF Lite, is that right? I think it was NRF Lite, isn't it? Anyway, I'm going to go now because I'm getting tired and it's been an hour and a half and I've not really achieved very much. Let's go actually, before I go, so this is what we've achieved. This rubbish schematic here, which doesn't have a lot going on. We've got a couple of caps, we've got our Nano board, which is the laziest thing I've ever done. I usually just create my own microcontroller board for these kind of things, like I did with this one here, which is much nicer. This one didn't work, unfortunately, but hey, so it's a bit lazy, and then we're going to be throwing on the NRF24LO1 Plus, and we've got a space for a DHT22 if we need to use it, and we're going to be using the LM35, which is a really easy chip to use. And we've just done our little board so that we've done our little PCB layout, excuse me. And we'll get it milled up this week. I'm not going to put any mounting holes on it because it really is just a test. If I do it properly, then I'll make the board an awful lot smaller and probably have the NRF sticking off to the side, but I'd like it all enclosed for now. And then I'll send it off to PCBs.io or something like that. But this one's going to get printed at my work. Anyway, thank you very much for joining me. I'm going to go now, so peace out all.